Assalamualaikum and a very good day. My name is Muhammad Ishamuddin bin Abdullah from Mechanical Engineering. Now, I will show you the outcome for the Structured Programming and Database System Assignment Project 2. So, this project I call as AC current analysis, which is to create single and three-phase waveform. Before I proceed to the problem statement, let me tell you the instruction for this assignment. To identify engineering-related problem or case study or situation by your own, design a simple application to solve the problem or this case study, which apply programming concepts that you have learned, which are any of decision structure, any of repetition structure, any of array and vector concepts, and text file processing. So, what is the problem statement for my project? Electrical and mechanical engineering students are required to come out with AC waveform during online lab. In lecture lab or usual lab, the students are able to see the waveform in oscilloscope, but during pandemic outbreak, students are unable to do so. Therefore, this project is designed to ease the students to generate their own single or three-phase waveform using C++ programming and Excel. What is oscilloscope? Oscilloscope or scope is used to test and display voltage signals as waveforms, visual representations of the variation of voltage over time. The signals are plotted on a graph, which shows how the signal changes. The vertical y-axis represents the voltage measurement, and the horizontal x-axis represents the time. This is the example for oscilloscope that usually be used in the lab. This is the example for single-phase waveform, and this is the example for three-phase waveform. For single waveform, we only have one wave. For three-phase waveform, we have three waves. They are developed inside the oscilloscope. Before we proceed to the programming, we should know what is the basic sinusoidal waveform and equation. So the basic formula that we use is amplitude time equal to amplitude, which is maximum, times with sine omega t. So this is my project called Virtual Oscilloscope. How the program works. So this is the algorithm. First, start the program, then declare all variables. After that, check if the input file name is similar to the guideline. Then if there is no required file, the program will stop. Else, if the file is existed, prompt the user to select the option in the menu. Number 6. Read the input file, which we get the frequency, the input voltage, and the time derivative. Then calculate omega and radians, and iterate the derivative time in vector function. You switch inside the do-while loop. For case 1, calculate and display the time and the voltage output for single-phase supply and write into single-phase supply.txt. For case 2, calculate and display the time and voltage output for the 3-phase supply and write into 3-phase supply.txt. Terminate the program if the user enters 0. Last but not least, stop the program. This is the C++ code snippet. First, we need to call all the libraries such as iostream, lstream, iominip, vector, and cmath. Like usual, using namespace std, int main. So system color for F to make my interface is appealing. First, declare voltage, angular frequency data type, and others, such as we declare the pi value, which is 3.1416, and other things like I, frequency, and T, analysis. That's all. Set the value of phase angle, which is theta 1 equal to 0, theta 2 equal to 1 to 0, and theta 3 is 240. Then create a vector for time of double type. So declare and open the files. So we need to name the file as data collection.txt. Then the program will create single phase supply.txt or 3-phase supply.txt from the user to enter the input file. So this is what will be displayed inside the interface of the program. Welcome to AC current analysis. If there is no data collection.txt, display no data has been found in the file, please save your data in data collection.txt. Else if the data collection is open, prompt the user to select the menu. Display select the analysis, 0 to stop, 1 single phase supply, 2 3-phase supply. The user should enter 1 or 2, is 0 to stop the program. Then the program will read the frequency, the voltage input, and derivative time. Here is the formula to calculate omega and radians. Omega equal to 2 times pi times frequency. Radian 1, theta 1 times pi over 180. Radian 2 equal to theta 2 times pi over 180. Radian 3, theta 3 times pi over 180. Iterate the derivative time, which is we need to use for the x-axis. So for the element 0, we set at 0.000. For element 1, equal to time derivative inside the file, input file. So we use for loop to generate the time for x-axis. This is a do while loop. Inside the do while loop, we have switch 1, switch 2, and default. So for the case 1, we calculate single phase output voltage, and then all the calculated value, which is the voltage output, will be stored inside single phase supply.txt. For the case 2, we calculate all the voltage output for wave 1, wave 2, and wave 3, and then will be stored inside 3-phase supply.txt. Default meaning that if the user enters 0, terminating the program. Last but not least, close all two files for if stream and off stream and return 0. This is the output for case 1. So after the user enter 1, this is what will be calculated. The result of calculated value will be stored inside the single phase supply.txt. And then we select all, copy and paste inside the provided Excel. And then automatically the wave will be generated. Same goes to output case 2. The result will be displayed and then will be stored inside 3-phase supply.txt. Select all, copy and paste to the provided Excel file, and then automatically the 3-phase wave will be generated. So if the user enter 0, will be displayed like this, terminating the program and then end the program. So that's all from the presentation slide. So after this I will show you the step by step, and then what should you do before, during and after running the program.